In this video, you'll learn how to count in other bases. In our system, we have a base 10 system, which means we have 10 symbols to represent numbers. Those would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Since we started with 0, that's a total of 10 symbols. If we were in another base, say base 5, we would need 5 symbols. And we always start with 0. So we would have 0, 1, 2, 3, 4. And since we started with 0, that's a total of 5. So if we're in base 5, we don't use the numeral 5. If we're in base 7, then the highest digit that we're familiar with that we would use would be a 6, because we always start with 0. So 0, 1, 2, 3, 4, 5, 6. And that gives us 7 digits to use for our ones in base 7. Now what if we have a base that needs more symbols than our familiar base 10 symbols? Say base 16. Then what we do, we still start with 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that just gives us 10 symbols. So we borrow capital letters from our alphabet to help us with the other symbols, because we need a total of 16. So there's 10. A would make 11, B would make 12, C would make 13, D would make 14, E would make 15, and F would give us a total of 16. So you need the number of symbols that you have in your base. Base 16 has 16 symbols, base 7 has 7 symbols, base 10, our base, has 10 symbols, and we always start with 0. Now let's think about place value. In base 10, if I have the number, say 253, that tells me I have 3 ones, I have 5 tens, and I have 2 hundreds. So the ones, that's not going to change in any base. In that digit, the last digit in your number, you can use any of those viable digits that we just came up with on the previous slide. So if I'm in base 5, I'm not going to see anything bigger than a 4 in that last digit. So let's go back and think some more about base 10. So we have the ones digit, and we can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in that place. And then once we get bigger than 9, then we move over, because 10 would be a group of 10, or 50 in this case. That means we have 5 groups of 10. Since we're in base 10, after we go to ones, then the next position is, let me not write numbers because that's confusing, tens position, because we're in base 10. If I'm in base 5, then my place values are going to go up in groups of 5, in powers of 5. So I have the ones here, and the next groups would be in 5s, and then the next group would be in 25s. How many groups of 25 would I have in base 5? And again, comparing that to our base 10, which we don't think about because we just use it all the time. But if you understand how base 10 works, you won't have any trouble understanding the other bases. But this 2 means 200. Well, 200 would be 2 groups of 10 squared, which would be hundreds. So in our base 10, the place values, we start with ones, and then we go to tens, and then we go to hundreds, and then we go to thousands, and so forth. But think about what that is. The ones are really your base to the 0 power, because any number to the 0 power is 1. So the ones are represented by 10 to the 0 power. The next digit to the left in our place values would be tens, which would be 10 to the first power. And the next digit over would be hundreds, which is 10 squared, and then thousands, which is 10 cubed, and then the 10,000ths, which would be 10 to the 4th. So if you quit thinking in terms of tens, hundreds, thousands, and think about what that means in terms of powers of your base, then you can figure out your place values in a different number system. So if we have base 5, the 1s are always whatever the base is to the 0 power, because anything to the 0 power is 1. And then the next digit would be how many whole groups of 5 do you have? And the next digit over would be the 5 squares, which would be 25, and the 5 cubes, which would be 125, and so forth. If we had a bigger base, like a base 16, then our 1s would be 16 to the 0. Then our next place value would be how many groups of 16 do we have? And then the next one would be 16 squared, which is 256. And in base 16, if you remember from the previous slide, we can use anything in here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Those are our digits that would be 1s. When we get one more than F, which would be a 16 here, then we would put a 1 here and start back over with zeros here. So let's see if we can count in a different base. So if I'm going to count in base 5, I need to review that the digits I can use are 0, 1, 2, 3, 4. So if I start counting, I'm going to count with 1, 2, 3, 4, and that's the highest ones digit I have. So when I get to the value of my base, the value of your base is always a 1, 0, because it's one group of whatever your base is and no 1s. And then we would start counting 1, 1 means that's one group of 5 and 1, 1, so that would be the equivalent of 6. And we just count again, 1, 2, 1, 3, 1, 4, and I'm in base 5, so 4 is as high as I can go in the 1s digit. So then I'm going to carry over, and this becomes a 2, and I start back with 0. And think about what that means. That's two groups of 5, so in our number base 10 system, that would be a 10 plus a 0, so 2, 0 represents 10. And then I would go back in that same 2, 1, 2, 2, 2, 3, 2, 4, and again, can't go higher than 4 because I'm in base 5. So then I start 3, 0, and continue that process. Now, that's not too bad when we get to use our symbols that we're familiar with, but what about when we have to use those letters? It's kind of mind-boggling. So in base 10, remember the symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm in base 16, so I have to have 16 different symbols to represent numbers in the ones column. So I'm going to use A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15, and that makes 16 digits because remember I started up here with 0. So now F is the largest thing that I can put in the ones column. So when I get to F, then I go over and I have one group of 16 and no groups of no ones left over. Then after 1, 0 would come 1, 1, 1, 2, 1, 3, 1, 4, all the way up 1, 9, 1A, 1B, 1C, 1D, 1E, 1F, and then F is as far as I can go, so then I carry over and I would have 2, 0. And then I go through 2, 1, 2, 2, 2, 3, and all the way up to 2F again, and then it would be 3, 0, 3, 1, 3, 2. So now let's back up. We're counting nicely in this, but what number would it be in base 10? So a 3, 2 means I've got 3 groups of 16, so that would be 48, and then I have 2 1s left over. So a 3, 2 in base 16 would be the equivalent of 50 in base 10.